All right, so let's get into actually doing some integrals, okay? So this is evaluate, and basically what that means is integrate it. Tell me what the integral is going to be, right? So again, when I'm integrating, it says, hey, this is the derivative of some function. What's the function? We're just going backwards, okay? So we use the power rule on this one, x cubed. We just use the power rule. And we know that the power rule says x to the n plus 1. The integral would be x to the n plus 1 over n plus 1. Okay? So the derivative of some function is x cubed. What's the actual function? So we take x to the 3 plus 1 over 3 plus 1. So that's x to the 4th over 4th plus c. I maybe should write that in red. Plus c. Oh, don't forget the constant of integration. Okay. So then, that's it. That's what the power rule does. The integral of x cubed is x to the 4th over 4. And you could check that. You could say, well, what? Let's make sure that's right. That's our function, x to the 4th over 4. Or you could write it as like 1/4 x to the 4th plus c. And if we found the derivative of that, what would it equal? Well, we'd take the 4 down, and we'd have 4 times 1/4, which is 1. And then we would subtract 1 from the 4, which is 3. So it really would come out to x cubed. So I would say, like, the biggest issue most people have with integration is they forget the plus c. And the second thing they do is they forget this little piece down here, the n plus 1. So a lot of people would integrate this and just do x to the 4th. But that wouldn't work, right? Because if you tried to derive x to the 4th, you get 4x cubed, not just plain old x cubed. So let's look at the second one. This one is a constant. So if you again you think, like, what function, when I take the derivative, is going to equal 2? Well, the function is, this is basically, that's 2x to the 0, right? So I add 1 to that, so that's 2x to the 1st over this number right here, which is 1. So really, it's just 2x plus c. And that's the constant rule of integration, remember? Like, if you have a constant and you want to integrate it, you basically just put x underneath it, or x next to it. It's just a fancy way of thinking about the power rule. But, and then let's look at the sum rule. Okay, so remember the sum rule, we can split integrals just like we could split derivatives, right? If I took the derivative of something plus something else, I could split it into two different derivatives. And I can split the integral as well. So this could be the integral of t to the 4th plus the integral, I should not forget my dt, plus the integral of 2 dt. Okay? So I just split it if they're adding together. It doesn't work if they're multiplying, just like derivatives don't work if they're multiplying. There's special rules if we multiply. Right? But when we're adding together, we can just split the two of them apart and then evaluate them separately. So the integral of t to the 4th dt, now that dt tells us that we're integrating with respect to t, right? So this is like, it would have been like dy dt, or not dy dt, dt dy would have been like our function, and we go backwards. We're going backwards from that. Okay? That was probably more confusing. Anyway, t is our variable. That's what the dt tells us. Okay? So what we do is we take, so if we're going to integrate t to the 4th, we add 1 to the exponent, and then we put it over, we put that same number underneath our variable. So we have t to the 4 plus 1 over 4 plus 1, which is t to the 5th over 5. And then we do it same with the 2. So that's plus 2 to the x 0 plus 1 over 1, right, which is just plus 2x. Oh gosh, I did it with an x, but it should be a t. See, I just gave you a whole speech on how t is the variable. And I did it with an x. Okay, t. Okay, there we go. That's t. And so really our integral is 1/5 t to the 5th plus 2t. Let's see, plus c. Don't forget the c. All right, there's our integral. Let's take a look at another one. We're going to integrate this one right here. This is 2y squared plus 4y. See, they're all a sum, so we can just split them apart. So this is the same as the integral of 2y squared dy plus the integral of 4y dy plus the integral of 1 dy. Now you might think that dy is weird, that it's redundant. It's not. You need to write it every time. Because look at this last one. If I said, what's the integral of 1 with respect to what, right? Because the integral of 1 dy is 1y, right? But if I just say, like, what's the integral of 1? It could be 1x, 1w, 1t. It could be any variable, right? So I have to have that dy. So what's the actual integral of this? Well, we do 2y to the 2 plus 1 over 2 plus 1. Plus 4y to the 1 plus 1 over 1 plus 1 plus 1y to the 0 plus 1 over 0 plus 1. And in the end, we're going to have 2y to the 3rd over 3 plus 4y squared over 2, which is going to simplify to 2y squared, plus y. And then what can't we forget? Plus c, right? Because there could have been some constant there that we took a derivative of, and it became 0. We never even saw it, okay? So that is that integral right there. Let's try the next one. The next one is, it looks a little more complicated, but we got this, okay? So, I think I'm going to erase all of this really quick so I have a bit more space. Okay, I'm going to write over here on the on this over by number 7, but just know I'm doing number 8. Okay, so this is two separate integrals, right? The integral of 3 over x squared dx minus the integral of 1 over root x dx. So that's the first step, is we want to split anything that's adding and subtracting. And then we can look at this and we're like, we don't really know how to integrate that, but we could rewrite them as exponents. So let's rewrite this as the exponent. This would be the integral of 3 times x to the negative 2 minus dx minus the integral of x to the negative 1/2 dx. And we know how to do that. All we have to do now is we can do, well, the integral of 3x to the negative 2 would be 3x. Now we take negative 2 plus 1 over negative 2 plus 1 minus x to the negative 1/2 plus 1 over negative 1/2 plus 1 plus c, and that equals, well, x to the negative 2 plus 1 is just x, right? So I have 3x, or it's just negative 1, sorry, negative 1 over negative 1 minus, what is negative 1/2 plus 1? Well, it's positive 1/2 over positive 1/2. So then we do some algebra and we get this as negative 3x to the negative 1 minus 2x to the 1/2 plus c. And you could rewrite that as negative 3 over x minus 2 root x plus c. You have lots of options there, but there you go. That is your integral. And if I took the derivative of that, I would get to our original problem. Okay, one last one in this video. The integral of x plus 1. Okay, so the first thing is we need to write this as the sum instead of a quotient because we don't know how to do quotients yet. So we're going to write this as the integral of root x over x squared plus 1 over x squared dx. Then we're going to split the integral, root x over x squared dx plus the integral of 1 over x squared dx. Then we're going to write these in terms of exponents. So that's going to be the integral of x to the 1/2 times x to the negative 2 dx. Oh, and there's the bell. So I guess I will finish this in a few minutes. Okay, so we're writing this as exponents. So x to the negative 1/2 times x, or x to the 1/2 times x to the negative 2 dx plus x to the negative 2 dx. And then, again, we have a product. Sorry, I should put the integral of x to the negative 2. We still have a product in there, so we need to take care of that product. But they're the same variable, so we can just multiply them together, right? So when we multiply them together, they add I think my note's wrong. Okay, so we multiply them together, they add, and we get, let me just check. So that becomes x to the negative 3/2 dx, right? Because negative 2 plus 1/2, negative 2 is 4/2, plus 1/2 would be negative 3/2, plus the integral of x to the negative 2 dx. And then now we can finally integrate. So we did all that work. Now we're just going to find the actual integral. Okay, so the integral of this, we would go x to the negative 3/2 plus 1 over negative 3/2 plus 1 plus x to the negative 2 plus 1 over negative 2 plus 1 plus c. And then we just go ahead and simplify those. So negative 3/2 plus 1 would be negative 1/2. That would be negative 1. That would be over negative 1/2 and over negative 1 plus c. Let me go ahead and move that up so it's not underneath my face. And so then we can just, we can write this, simplify a little bit more. Divided by negative 1/2 is actually multiplied by negative 2. Minus x to the negative 1 plus c. You could leave it like that if you really wanted to. You could write it as negative 2 over the square root of x minus 1 over x plus c. It just depends on what you were doing with it next. But there you go. There's some basic integration, and we have one more video on this.